Hello, my name is James Upton, and I'm from Grade Junior School. I hope you enjoy my science project, Wasted Energy. Introduction. The supply of electricity and paraffin in outlying and rural farming communities is unreliable and expensive. These sources of energy are essential for the use of cooking, heat, and light. With this in mind, there is a real need in these communities to make the energy supply self-sustainable and the development of homemade renewable energy sources, like informal domestic biogas plants, are required. Aim. My aim is to analyze which manure, when combined with pineapple and water, will produce the most amount of biogas within a set period of time. The experiment will include the manure from typical livestock found in rural areas, namely cows, horses, chickens, and pigs. Each of these will be combined with the skins of pineapples, which are grown in the Eastern Cape. This information will help inform rural farming communities which livestock they should have to produce their own supply of energy. Hypothesis. Before I started my experiment, I did some research and found out that most organizations that manufacture biogas plants use cow manure. The reason they use it is because you actually can't have too much cow manure in the world, as it releases so much gas that it negatively affects the ozone layer. Given that cow manure has a reputation of producing a large amount of gas, surely it will produce the most amount of biogas, methane, compared to the other livestock manure in our experiment. So with that in mind, I predict that cow manure, when mixed with pineapple skins, will produce the most amount of biogas after the 21 days. Background information. It is 5:30 on an icy Eastern Cape morning in Perry. The animals in the village are starting to make their noises as the sun starts to rise. Lisa is already on her way back home with a large heavy pile of wood balanced on her head. She is in a hurry to get back because the children will be hungry when they wake up, and she still needs to start the fire to cook their breakfast before heading off to work on the pineapple farm. The wet wood is now her only source of energy, as last week she ran out of paraffin. She wishes that she could just simply flick a switch and her stove would come on. This is how many households in the rural areas start their day. The luxury of simply switching on a stove is something they cannot afford. Being in the Eastern Cape, pineapples are one of the major locally produced crops. With their high sugar content, pineapples are one of the best fruits to make biogas. With the use of pineapple skins and manure from livestock, these rural farmers can produce a cheap and reliable source of energy to support their lives. By having their own self-made biogas plants, the farming community will save money on petrol and paraffin and save time where their efforts can be used on more productive activities such as farming and working. This need was the inspiration behind this project, as I realized that there was an opportunity to help self-subsistent farmers in outlying rural areas by providing them with the information required to make their own renewables energy with ingredients that they already have: manure from the livestock and pineapple waste. The answer is biogas. So what is biogas? Biogas is a blend of gases that are produced by the decomposition of organic waste, fruit and animal waste, in an anaerobic environment. Biogas contains mostly methane, CH4O, and carbon dioxide, CO2. One of the main gases released is methane, which is combustible and is ideal for gas stoves and heating geysers. Method. In this experiment, we will determine the amount of biogas produced by the size of the circumference of the balloons. Firstly, I collected all the manure, cow, chicken, pig and horse from the same farm to ensure each type of animal was fed the same type of food. This really stank. Secondly, I bought pineapples from the same supplier and cut the skins off of them. Unfortunately, this project put me off pineapples for a while. I used 19 identical 1.5 litre bottles as my mini biogas plants. I then measured 40 grams of pineapple skin per bottle. I measured 80 grams of manure per bottle. The weighed manure was put into the bottles and mixed with pineapple and filled with spring water. This was a really messy job. I put a balloon over the neck of each bottle and sealed it with insulation tape to ensure that the gas does not escape. I repeated this method across all 19 bottles. There were 5 bottles per manure type, except for the chicken, where there were 4. Every single night at the same time, 7 o'clock p.m. For 21 days, I measured the circumference of the balloon with a piece of string and ruler. Unfortunately, my garage was really smelly after this. I then captured the results in an Excel graph. Variables. Controlled variables. Pineapple. Same quantities. The quantity of manure in the bottles. The bottles, same size and make. Balloons, same size and make. Spring water, same brand. Independent variables. Cow manure, chicken manure, horse manure, and pig manure. Dependent variables. The amount of biogas produced. Size of the balloons during the experiment. The results. The following slides will indicate the results of my project, which we will discuss later. Cow manure and pineapple mixture. Horse manure and pineapple mixture. Chicken manure and pineapple mixture. Pig manure and pineapple mixture. Discussion of results. Cow manure and pineapple mixture. On day 5 of the experiment, the cow manure produced the most amount of biogas, inflating the balloons to an average circumference of 58.8 millimeters. The largest circumference on this day was 160 millimeters. Interestingly, day 5 was also the hottest day experienced during the period of the experiment, with a temperature of 32 degrees Celsius. Overall, the cow manure in this particular experiment performed poorly compared to my preliminary tests, which it actually did quite well in. On most days, the balloons just simply didn't inflate. Horse manure and pineapple mixture. Day 12 of my experiment was the first time I saw any activity from the horse manure balloons, inflating to an average circumference of 22 millimeters. On this day, only one balloon inflated with a circumference of 110 millimeters. Day 5 was the hottest day experienced during the period of the experiment, with a temperature of 32 degrees Celsius, and yet the horse manure didn't produce any inflated balloons. The performance of the horse manure was in line with what I experienced in my test experiment, as the horse manure needs a much longer period to produce biogas. Chicken manure and pineapple mixture. The chicken manure experiment was observed over 4 bottles and not 5. This was due to not having enough pure chicken manure. Like the cow manure, on day 5, the chicken manure balloons produced excellent results, inflating to the 3rd largest daily average of 102.5 millimeters across my whole experiment. Unexpectedly, day 20, at a temperature of only 17 degrees Celsius, saw the balloons inflated to the largest daily average of 108.5 millimeters. Pig manure and pineapple mixture. Like the cow and chicken manure, the pig manure performed well, reaching its top daily average circumference of 81.6 millimeters. In fact, this result was second to chicken manure on day 5. This made me believe that pig manure would produce good results over the period. This was then proven wrong with a massive decline in the daily average circumferences over the period of my experiment. The pig manure over this period of my experiment produced disappointing results. Discussion of results. The top performing manure with pineapple was chicken manure. It produced the most amount of biogas over the 21 days. Cow manure with pineapple produced the second most amount of biogas. Pig manure with pineapple produced the third most amount of biogas, and horse manure was last. Chicken manure's average amount of biogas produced was amazingly almost double the amount of the cow manure's average biogas produced over the 21 days. On the hottest days, there was a huge increase of biogas produced across all the manures other than the disappointing horse. On the colder days, there was a significant drop of biogas produced. Conclusion. Contrary to my hypothesis, I predicted that cow manure would produce the most amount of biogas. It was in fact the chicken manure that produced the best results. It was almost double the amount of biogas from cow manure produced over the period of my experiment. This is a positive outcome for the farming and rural community, such as Paddy, as chickens are much easier to own due to their low maintenance costs. They require far less land and they lay eggs, which is a good source of food. So when it comes to chicken manure, don't waste energy getting rid of the manure. Rather extract the energy from it and create biogas. Acknowledgements. From early morning collecting manure to late night data capturing, I'd like to thank everyone who has contributed to my science expo. Homely Farmyard, who kindly opened up the gates for us to collect the manure. Animal Welfare, where we collected manure for our test project. The horses and donkeys were rewarded with carrots and apples. My brother, who helped collect the manure. My grandpa, who assisted me with the original project idea. My dad, who helped me throughout my project and had to practice lots of patience. Bibliography. The following sources are where I got my information and pictures from. Behind the scenes. Below are photos of me collecting manure from the animals. Here we have photos of us actually making the biogas plants. This was a messy and smelly job. I hope you enjoyed my wasted energy project. Thank you for your time.